Hello everyone, and welcome to the GPFM National Pilots webinar series. This is actually our seventh webinar in the series, and today I'm delighted to be joined by Daniele Porco from Enel Grids in Italy, and he will introduce himself shortly. But first, for anyone on the call who's maybe unfamiliar with mission innovation and the Green Power Future mission, I'll give a bit of an introduction to that. So, Mission Innovation was launched at COP21 in 2015 and is a global initiative catalyzing a decade of action and investment in research, development, and demonstration to make clean energy affordable, attractive, and accessible for all. Can I just ask that everyone mute their mic, sorry, so we don't have any background noise? Okay. Mission Innovation is the main intergovernmental platform for accelerating clean energy innovation, and it involves 23 countries plus the EU, represented by the European Commission, as well as several collaborating organizations you can see on the right-hand side there. And so these members are responsible for over 95% of public clean energy RD&D investments globally. And MI is structured around 7 missions, which are public-private innovation alliances that are setting goals that will lead to tipping points in the cost of and scale of energy, clean energy solutions. And so the 7 missions are at the bottom there, but we are the GPFM, so I'll be going more into detail on that. So the GPFM's goal is to demonstrate that by 2030, power systems in different geographies and climates are able to effectively integrate up to 100% variable renewable energy in their generation mix, whilst maintaining a cost-efficient, secure, and resilient system. And we do this through knowledge exchange and capacity building by demonstrating innovative solutions and generating the tools, data, and networks needed to enable more regions to be powered by affordable VRE. So like all of the other missions in MI, the GPFM is a public-private partnership made up of in-kind contributions from its member countries and organizations. Italy, China, and the UK are the co-leads, and you can see here the many other members that we have in our coalition from around the world and in the private sector. The GPFM splits its work across 3 main pillars. So the first, which is led by China, focuses on the generation of VRE from the likes of wind and solar power. The second pillar, led by Italy, focuses on the grid, system flexibility and market design and regulations. And the third and final pillar, led by the UK, focuses on the data and digitalization of the electricity system. So within these 3 pillars, there are 50 urgent innovation priorities that were identified by the mission that we wanted to address by 2024. And we're actually in the process of expanding this list to include additional priorities that need to be addressed. And this will all be published quite soon in our action plan for the years of 2025 to 2027. So keep an eye out for that. So to tackle those innovation priorities, in 2022, the mission launched its first flagship project titled 5 Demos in 5 Continents. And so the goal of this project is to establish 5 large-scale demonstrations of innovation activity in the 5 continents of Asia, Australia, Europe, North and South America. So these demonstrations are made up of 80 national pilots on the scale of millions of euros. And these are tackling one or more of those 50 most urgent innovation priorities that I mentioned. And you can find more information about all of the pilot projects in our National Pilots Report, which is published on the GPFM section of the Mission Innovation website. Now, this webinar series was launched last year as a way to facilitate the sharing of knowledge and lessons learned from these pilot projects. And we've had 6 contributions so far that you can see on the screen. And the recording of all of these you can access through the Mission Innovation website. And then lastly, let me just tell you about the GPFM Toolbox. So this is a publicly accessible repository of all the information pertaining to the GPFM, including details about all of the pilot projects that I mentioned. And here you can also access everything that the mission has produced, including publications like the National Pilots Report, insights reports, and the recording, again, of all of these webinars. So feel free to head over there and keep up to date with what we're doing. Okay, so back to today's agenda. We're going to be hearing from Daniele about the great work that's been happening in Italy at Enel. We want this to be an interactive discussion, so please use the Q&A function or the chat to submit questions at any time throughout the talk. We'll get to them at the end. And you'll be able to raise your hand throughout as well if you want to participate that way. And I think Daniele has some plans to try to get you involved. So with that, I'll hand over to Daniele to give us his talk. So Daniele, the floor is yours.
Thank you. Let me just check if everything is working concerning screen sharing, and is the typical question when we start. Can you see my screen?
I can indeed, yes.
Okay. Thank you all for joining this webinar today. My name is Daniele Porco. I'm working for Enel Grids since 1996, so it's been almost a life. And in the last almost a decade, I'm working in a subsidized program in Enel Grids. Let me briefly introduce Enel Grids for those who are not aware. Enel Grids, it's a company, a subsidiary of Enel Group that coordinates the activities of all DSOs in Enel Groups, involving more than 32,000 people, having 1.8 million kilometers of power lines over 6 countries. We have a total of 68 million final customers, and the plan for the upcoming 25-27 years is around 26 billion euros. Of course, these are the global numbers of the company, but as a team, we are supporting the participation of all the DSO of Enel Groups to international projects. Since around 2000, we are supporting a series of projects. Just to give you some highlights, I was not going to the Neanderthal period, but there are a series of milestones over the time that you see that the topic of research of European funds was changing, and it was kind of anticipating the new trends, and we were there in each and every milestone. Today, I'm focusing on TwinEU project. I'm coordinating the Italian cluster of companies who are participating, and the Italian pilots. So I don't know how many of you knows the project. I think you have the opportunity of raise your hand. I just want to understand how many of you are from DSOs or TSOs, for example, if any is connected, just to me for understanding. Okay. How many from energy generation, for example? No. Research institutions? I see a series of known names, Mattia and others. Okay. And the last but not least, for aggregation, market side, and whatever is beyond the meter. Okay, great. Thank you. So I will give also some more information on the point of view and the perspective of a system operator. Talking about TwinEU, TwinEU is a large project that covers the topic of digital twins, and since it's not possible to build pan-European digital twin of the energy system, The project is focusing on the federation techniques, okay, fostering the interoperability among different twins. As I mentioned, the project is very, very big. We are more than 75 companies, including, you see in the bottom line, a series of companies that were committed to participate to the project with zero budget. So just to highlight that the project is very relevant. We have 14 TSOs, 14 DSOs, and a lot of members. And the project is started last year, so we are almost at the middle of the implementation phase. And yeah, let me give you some other detail. We tend to identify two streams. One is the horizontal stream, that it's about platforms. So the platform will provide all the tools to build this interoperability among different twins, and also the interconnection with the European data space, leveraging the OneNet connector that it was developed in some previous projects by the coordination team. And there are also vertical streams that are the pilots, and we will focus today in the Italian pilot. As I got to understand from Craig's presentation, all the participants to this pilot are also a member of this framework of mission innovation. Okay, so together with Terna, the Italian DSO, Enel Grids, and its affiliated entity, Distribuzione, the major DSO in Italy, Areti, who is the DSO of the city of Rome, and CL is a consortium of the Electricity Engineer University. Specifically, we are working together with Politecnico of Turin, University of Genova, University of Naples Federico II, and the Politecnico of Bari. Then RSC is the research institution for investigating the energy system, and we are kind of guests by Luciano. NLX is another subsidiary of Enel Grids that operates in retail market and new technology. And yeah, we are implementing actually two pilots. One is the design validation and the defense system. So let me start from the defense system use case that it's very relevant for the TSOs and focuses on the system stability. So what is the defense system? The defense system, it's a series of strategy, rules, and also equipment on field to preserve the stability of the energy system through a series of services like ancillary services. What is the actual state of the art? Let me mention that this defense system or some strategy to preserve the stability have been introduced in Italy starting from the 70s, more or less, when they introduced a scheduled curtailment of the energy because of the energy crisis, the oil crisis. So from time to time, there has been a series of devices installed on field and a series of rules to be respected to preserve the stability. And it was working pretty much well in the, let's say, waterfall version of the energy system, when the generation was concentrated in a big power plants, and energy was transported across the country and distributed. So this is the schema of the high voltage, mid to medium voltage substation of the DSO. And actually, the main device in the DSO premises is called ARC. It's an automatic load balancer that it keep on analyzing the frequency and also the time derivative on how the frequency is changing. And there are a set of rules and a set of medium voltage feeders that can be opened to prevent major disruption in the grid. What happened that with the pressure of the distributed generation, this kind of relay, this kind of tool, it started to show its limitation. One of the limitations is that the thresholds or the set points are updated once or twice a year. From the moment we started the project, we got to know that also ENSOE, the Association of Transmission System Operators in Europe, is making an investigation to understand how to solve this issue and to make it more flexible somehow. So we are really working in a very spot-on problem for the energy grid. The other point is that the modern relays for the feeders and for the other equipment has a series of extra features that hasn't been tested so far. So there is the opportunity in this pilot to leverage on these extra features and try to understand if they are working. So what is the scenario? The scenario we're talking about Italy. Italian transmission grid is connected to the pan-European grid, except for the transmission grid of Sardinia. Sardinia is the second biggest island in the Mediterranean Sea and is connected in DC. So the problem, I was just quickly summarizing some of the pain point and why it's relevant to implement this pilot in Sardinia. Actually, apart from the connection in DC, according to the rollout plan of the decarbonization, there is a phase out of coal-powered generation plant. There is, as I mentioned, a constant increase of distributed generation that is subject to season changes, as well as the loads, the requests from the customers, because of in the tourist season, the island goes from 1.5 million of peoples, resident people, to above 6. So it's a complete shifting in the change of the season. What is the trouble for the TSO? That first of all, the TSO has to ensure the frequency that is originated and maintained and controlled in the island. So there is no contribution from the pan-European grid. And the second is that whenever there is an adjustment to the rules, maybe trimming one of the threshold of these devices, you need time to understand what is the correction and what is the reaction of the grid, and maybe after 5-6 years, it turned out that that parameter was not correct or that approach was not correct. So, as I mentioned, the project is about digital twin. So one of the way how to implement digital twin is the real-time simulation. So we will actually Terna Rete Italia is implementing a real-time simulation of the Sardinian grid, and it will be interconnected with the Politecnico of Torino to simulate the reaction of all the components of the grid, including the generators. There are a series of hydroelectric power plant, 2 or 3 coal and oil power plant, and a series of renewables. So through this system, it will be possible to understand in a specific scenario, replicating the reality, let's say, how the electrical system is reacting. The main architecture is based on, let's say, OPAL simulators, and they are interconnected through VILAS framework. This allows a federation. It's like federated by design of different twins. In all different simulators, there will be the transmission grid, as I mentioned, the generation plants, but also a portion of the Sardinian grid of distribuzione. So what is the innovation? The idea is to build scalable models for data exchange in real time. The introduction of digital twin feature for dynamic simulation, and as I mentioned, the native by design federation of the digital twin, fostering the reliability and the stability. For example, if you make a correction or a change in one of the elements, you are not changing the full simulator, but only one of the federated elements. So it's the system will be more stable compared to the to other previous approaches. Concerning the TSO grid, here it's simplified only with transmission level high voltage grid in AC. The connection in DC is and the high voltage power line for connecting the distribution is not highlighted in this schema. What are the features of the tool? There will be a network state monitoring, a series of security analysis to understand the grid security and situation. It will be also implemented and interconnected, let's say, with the operational planning, and also there will be an assessment of the emergency management to understand what could be the steps in case a disruptive event occurs. For the DSO grid, there will be a series of elements like the network state monitoring, the operational planning again, and also the emergency management. We will also address the modeling of the aggregated renewable resources, and for this there is the cooperation of NLX colleagues. So one of the area of investigation will also include and involve the distributed generation. As far as I know, there are no model for how the distributed energy resources are working in operational level, because all the projects about flexibility covers only the let's say the market layer of the flexibility. So the traffic light, the priority, if it's the bid is for the DSO or the TSO and so on, but nobody still investigated how those generators and inverters can contribute in critical condition of the grid. So I think it's quite interesting for everybody. So expected outcomes, because the project is still on progress, so I can't bring any preliminary conclusion. We are still on the implementation phase, but we are trustful that there will be some outcome very soon. Actually, the goal is to implement this testing platform to test the new rules. So as I mentioned, the process of creating new rules nowadays is quite complex and long. I think this, or we think this approach could accelerate the creation and the validation of new rules without disruption in the grid. And then the idea is to test the new rules developed for the specific case, a specific situation of Sardinia in the urban metropolitan grid of Rome. So let me highlight the contributors of this pilot. Terna is coordinating the pilot of the defense system. The grids involved are belongs to a distribuzione reti. I forgot to add, sorry for that, NCL, that is providing all the expertise and the technical knowledge to support the simulation. Okay, I don't know if there is any question about this, or we will check the question at the end. I don't even know if I'm running too much, but let's move to the next use case about the design validation. We are talking about planning and building new transforming power plant, primary substation or TSO power stations. I don't know if there is any civil or electrical engineer in the room who is expert in construction of new power plant, but let me spend a few minutes to introduce BIM, building modeling, information modeling. It's let's say a complex model that describe the construction project, the construction design in its complex articulation, let's say. To give you an example, there are a series of, let's call it, layers to identify all the objects, like for walls, doors, steel structure, pipelines of gas, water, electricity, and so on. But also for each element, all the materials. For example, for the walls, let's say we have layers for bricks, the concrete, plastic nets, plaster, coating, insulation material, and so on and so forth. So together with a series of metadata about the physical characteristic of the material. So the system was born for construction industry, but it encompasses a series of features that makes it very relevant for the construction of new power plants. The BIM encompasses all the life cycle of the building, let's say, from the planning phase, design, building, and operation. Okay, so this is for civil engineering perspective. What happened with the energy grids and in general with energy infrastructure? Actually, we have a constraint because of Italian regulation that for a system operator, it's mandatory to follow the national rule for public tenders. Okay, so for all the projects of over 5 million budget and building a new substation, it's mostly likely to be within this perimeter, is mandatory to have the beam planning. Is not only suitable for the construction, but also for example, the environmental impact, or the impact with some sub-services. You can imagine in a city like Rome, just to mention that Arete is it's part of the project partners. And whenever they move anything in the city, there are 35 meters of layers of history. So it's very complicated, and you need to be very sure of what is under the ground before to start to position any brick. We started a preliminary investigation in Spain. Actually, Enel, as I mentioned, as a subsidiary in Spain, and the regulation it's different because it's not mandatory for them to issue new projects using beam, but they already had experiences. By the course of the project, we will check how the regulation, the European regulation, actually has been incorporated in the national regulation. And then, last but not least, for the energy industry, there is no automatic tool for the design. Just to give you an example, in the civil engineering, when you design a door in a wall, the system automatically calculates the cutout, so that amount of material is not part of the plan anymore, and is inserting a door. So there are a series of tools for the steel industry. Is the same when they need to join two steel plates with nuts. The system is automatically calculating the diameter of the holes and a series of facility for the steel industry. That those two I know. For the other side, I don't know if there are other facilities, but for energy industry, there is nothing that it's checking the connectivity between elements, and this is very relevant for the industry because you only have the beam model, for example, of the transformer, because the manufacturer can provide the beam for the transformer, all the inner components, parts, layer, and so on. But whenever you connect, I don't know if you can see the pointer. Let me light on the pen. Okay, whenever you connect the wiring to the transformer, there is no coherence with the connection. Okay, I will go later on this point. Let me explain, or let me summarize what are the design phases. Before I mentioned the 4 phases: planning, designing, building, and operating. Actually, the outcome of the planning part is a sort of preliminary design. For example, I need to build a primary substation with 2 transformers, only 1 high voltage line, for example, and 5 feeders in medium voltage as an exit. And this is something as a, let's call it, functional pre-requirement. So we need to build this kind of power plant. And there are a series of interim designs, like a high-level plan for the authorization phase. There could be authorization prescription, so there is a set of prescription that has to be observed, and then this phase will be concluded with the authorized design, as a high-level design. And then the final one is the so-called executive design. So is the design that is needed for the physical construction. Moreover, everything has to be compliant with the design standard. For example, I will tell you a series of content about the standard. So it's just to summarize, what are the rules for not only for the concrete, for the steel structure and so on, but also for the energy requirement. So all the distances, all the way how to build, what kind of material, etc. So in the validation phase, we need to verify that the preliminary design and the design standard are coherent and fully fulfilled with the executive design. Why this verification process is needed? Let me mention the two main actors of this pilot. Enel Grids, who is coordinating, and Terna, who is also implementing design validation tool. For Enel e Distribuzione in particular, the company is hiring external professional to design the substations, because it's quite a specific competence, and during the turnover it happened that there are no more technicians to do that, and also the prosumer by Italian regulation are able to provide the design and to build some portion of the distribution grid. For Terna, is not they are not allowing to build the transmission grid element, but they have the problem to validate the design made by a energy producer or by prosumers of transmission grid elements. So both Enel and Terna has the same problem of validating someone else plans and designs, and the problem is that with BIM it's very, very complicated. But I don't want to anticipate any topic. Let me go ahead with my presentation. To make it easier to understand, I like to make the parallel with the traditional design. In the background, as you can see, we have a design of old high voltage to medium voltage transforming station from the 60s. So I'm not even mentioning AutoCAD or other digital topics. We are going to the basic to have clear what is the concept of design and the validation process. So whenever you ask a designer to provide a plan for a new construction, new building, and a new grid elements, there are a set of elements that has to be provided by the designer. All the plans for foundation and buildings, so whatever is concerning civil works, the design for the electromechanical equipment, so exactly in the plan how they are positioned, interconnected, etc. And then the functional diagram, so the single line design that it's needed to understand the coherence with the requirement. As I mentioned, BIM is not providing the single line design, for example. So this is a big problem still open that the designer can't provide using a single model all the elements. So, but for foundation and buildings and the electromechanical equipment, so whatever is physical construction, the model it's already there. Let's go to see the validation phase. Okay, validation phase again in the traditional design. You see here that there was some corrections. So the validation process was about checking what was done by the designer, integrating it, and making things work after the approval phase. So the steps are, let's say, the same by abstraction. So we need to check if the initial needs are satisfied, how many high voltage inputs, configuration, the number of transformers, how many feeders, the coherence with the design standards, the coherence between elements. For example, if I have one transformer outside in the courtyard, let's call it. Sorry for my English; it's not always that good. If we have a transformer outside, we also need to have a series of relay and protection digital elements inside the building. So this kind of coherence has to be verified. And last but not least, all the safety distances. I know that it's also a part of the design standard, but it's not only about the distances, but also all the safety requirements during the construction. For example, for each and every work, there are a series of safety prescription, and those prescriptions could be embedded inside the beam model. But in the traditional way, there is a document about the safety that has to be provided together with the design. So what's up with beam? We were a little bit anticipating the topics, but the same steps done in the traditional design can be executed in beam. So the verification of the initial need could be fulfilled via an analysis of the bill of material. So to check how many transformers, you check the bill of materials, and you have two transformers, 5 circuit breaker in medium voltage, 5 circuit breaker in the bill of material. The bills, sorry, 1 second. Okay. The bill of material, it's also very crucial for the procurement phase, because when you start the design phase, you start to understand how many pieces of each and every material has to be ordered, and especially for the high voltage dedicated material is not a fast process. They are working, let's say, on demand. You need one transformer from high voltage to medium voltage, and they are building it according to your request. So it's quite crucial also in the timeline for the construction. Moving ahead in the validation side, we need to verify the compliance to the design standard. So one option is to provide the standard model for each and every component to ensure that the rules are observed, but there should be also a check and a verification that all the metadata provided with the design are verified. A certain class has to be declared in a certain way. The I don't know, isolation class for this circuit breaker has to be according to the standard, and so on. And this is the verification of the attributes for each element. And then the coherent check, as I mentioned, checking if there is a transformer outside, also all the relays to control the transformers inside the building. So making comparison through the bills of material can support this verification, and also the attributes check. Of course, this activity of validation, it's very, very, very complicated to be handled manually. And actually, since it's already mandatory to have bill models, from the moment we submitted the project proposal that we were thinking about the future to now, this period, the regulation was moving faster than expected. So my colleagues from E-Distribuzione are working hard to validate those attributes manually. So the pilot is very spot on, and it's already solving a crucial problem that it's showcased in real life. Last check is the so-called geometry checks. So it's not only checks on the attributes, but also checks using the geometry. Actually, for this kind of check, we don't have the element yet to make such verification. But we are working. I don't want to anticipate so many elements, but we are working on that to find some turnaround. So let me talk about the validator that we want to implement in the pilot. So the idea is to implement a series of rules so that an automatic tool could check if those rules are verified. For example, we need to understand what is the context, if the rule is applied to the general design, or by class of elements, or for the single element. The check type, we will see what are the file formats, because there was a change in the order of the slides. But I will explain you shortly what is this difference of IFC and native file check, and then the content of the rule are, let's say, not that complicated. It's like the rule you have in the Excel files that you can check values, making comparison, the tolerance level, checks on string, dates, attribute, and the severity of the warning in case the severity of the rule, in case the rule is not respected in the design. There should be an alert or a blocking error to be let's say analyzed further. The idea is that once the validator is working, it could be available directly for the designers, so for the contracted designers, that before submitting the design to the TSO or the DSO, they can run this validator and check if all the given rules are satisfied. Okay. As I told you, I want to mention the data formats again with an example. We all know AutoCAD. It's here from the 80s, if I remember right. I was a kid. In AutoCAD we have two formats. In the beginning, the DWG was the editing format, and DXF was the exchange format. In BIM, we have the same. So we have the files .ifc that stays for international. Is the international standard for the building smart, and it's an open format for the exchange data. So we can compare it to the DXF, while the so-called authoring format, it's a proprietary format for used by the software. So we have a separation among the different editors available on the market, that each of them use their own proprietary format, and an exchange format that is called .ifc. What both Enel and Terna are requiring to their designer is to provide, on the one hand, the BIM file, so the IFC file with the open format design, but also having a backup of the authoring format, because in case any editing is needed, we need to have the proprietary file. Moreover, some checks can be executed, and also already today, Enel is asking for for example, the clash detection. If there is any interference in the 3D elements, that it's a kind of verification for the geometry check that can be executed only in the authoring file. I don't know if it's clear. In case we can go back in case of doubt. Last but not least, the Building Smart has a format that is not dedicated to the validation rules, but could fit to our scope. So the first outcome from the project after the first year is that there is already a standard for the metadata, or the data structure for the rules. And we will work on the standardization tables to showcase our validator and fostering the adoption of the format to the rule. So as you see, the topics is quite complex. We can't cover all the issues related to BIM, but we are also cooperating with other projects. For example, the project Orion that started this year through the University of Aachen, that also belongs to the TwinEU project. We create a first interaction because they are very focused on the integration between BIM and CIM, to have a correlation between the physical design and the technical, let's say, functional design of the power station. Besides that, in the opening, I was mentioning the platform layer of the TwinEU project. There is a in the horizontal streaming, one pilot about the immersive reality. So the same team working in the design validation plus Areti that doesn't have already a beam, the implementation of beam in their system. They are supporting engineering, another partner of the project, in implementing an immersive reality tool to foster the interaction between the designer and the validator to understand where are the open point. In the example, there is a plinth under the high voltage structure, for example, and we can in the future verify if all the design phases are verified, if there is any discrepancy, if for example, the authorization phase for the single element it's complete, and etc. So this is a way how to start moving ahead in the implementation and the adoption of twins, because starting from the design phase, we develop the tools that could be also used in the future in the operational level. For example, there are plenty of immersive reality tools to support the technicians on field. And if we start populating the archives, the database using beams, it will be easier to develop all the tools to support the technicians on field, having, I don't know, a list of libraries of all the power elements. Everything is connected with immersive and augmented realities are moving in that direction. Okay, I think that's all from my side. I don't know if there are any question, but before closing, let me ask you to follow and support the project in our channels and social media. I will stop the presentation here. In case it's needed, I will go back to the slides.
Great, thanks very much, Daniele. We already have a question in the Q&A box, so I'll just read it out for you, but be prepared, it's quite long.
Okay.
So Sam says, this is all very exciting, but he got a bit lost in the presentation. So you started off talking about digital twins, but then you started talking about design phases. So are they design phases that pertain to designing a digital twin? If you are struggling to apply BIM in some places, which would only deliver a fraction of the information required for a digital twin, how far along the route to actually getting to a digital twin are you? And on that basis, what is your definition of a digital twin? And have you managed to cross the threshold so that it stops just being a couple of models that look a bit similar, but don't give you the whole picture and a live whole picture where you're using the twin to alter in real time rather than using two static models to see what might happen under new circumstances? Now that's quite long. I hope it was clear.
There are a list of topics, and thank you for the question. First of all, at project level, so let me differentiate the wide amount of partners that are composing the project from the Italian pilots that is very focused on specific application of digital twins. So at project level, we will give at the end of the project a comprehensive definition of what digital twins are. So we did already I'm going by heart in what are the activities from other teams. I'm not overseeing all the project, but we had a series of internal questionnaires about every single pilot, what we are doing, what is our concept of a digital twin, what is the meaning of having a twin, and what is the difference between the standard implementation of digital tools and the digital twin. So the definition of digital twin, it's very complex. That can encompass operational level, sensors from the field, the static model, the dynamic model. We have different visions. I mentioned real-time simulation. For example, we have in the same working group of the Italian pilot, a pilot in Slovenia, that they are melting together the static model with the dynamic model coming from the reality to make optimization of the grid, also in response of events. So from the operational level, there is several information flowing and feeding the digital twin to support this real-time simulation with real data. So there are different versions of what is a twin and what is not a twin. And in the adoption phase of the BIM models, we are coming from different experiences. For example, in Enel, there is BIM is already integrated, for example, with the supply chain, and from the design there is the already the integration with all the supply and procurement phase, and also the outcome from the design after the construction is finished are already going in the database of the grid. Let's say every component we are adding with the design, it will be inserted in the description of the power infrastructure. It's a series of steps to do that, but the integration it's already done. What is missing is the design validation. So this project is supporting the creation of the twin, fostering the design validation. From Terna's point of view, the adoption of BIM is only starting now because of prescription. They don't have a high level of like a number of design to be invalidated, because the changes in the transmission grid are, let's say, more diluted in the time, is lower than the distribution grid. Plus the distribution grid is under a full renovation due to the national and European funds for the resilience program. So there are a high number of designs to be validated, and the team who is doing the validation is really under pressure from the amount of work. So this tool is going in that direction, and it's a piece of a puzzle for the adoption. We are leveraging, or we will try to use this example of the validation to open a dialogue with the standardization body and support also the discussion, foster the discussion on the need for the energy system to be to have the same facility as for example, the building industry, the steel construction industry. So all this facility that is creating not only the mechanical connection, the mechanical join between the transformer and the copper bar, but also the electric contact for the single line design. So joining the physical and the functional design. That's a piece of the puzzle. What is missing? The project is limited. We are not working in an infinitive budget, but in the same time, having such a wide group of participants, we will make internal investigation among the system operators, the two associations, ETSO for Smart Grids and ENSOE are part of the project. The DSO entity, it's a follower. They are following our activity from close distance. So we will go together to the standardization body to knock the door and say, look, we are those cool guys who are working hard to provide some interim result on the analysis, some approaches. Of course, we don't want to rewrite our software once the project will be finished, because it will be already used after the project is, or during the execution of the project. It will go online directly. And I think it's a good support also for BIM, because the topic and the problem of validation is not only for power plant. Every time there is a design for, I don't know, a new oil plant or a new district of urban area, there is a validation process to be implemented, and is not existing. So, with the excuse of the energy digital twin, we are trying to contribute to the evolution of this. I hope that the answer was covering. Thank you.
Okay, great. So I don't see any more questions coming through at the moment. So I think I will ask a question while others can hopefully write theirs in. Also, just as a quick reminder, if anybody would like to, if you're feeling brave enough, you can raise your hand and unmute and ask verbally, but you don't have to. So my question was going to be, I guess, a little bit more high level, just about the fact that this TwinEU program, you showed at the start, there are 75 different kind of stakeholders in it. So that's huge, and they're all over Europe. That's not just Italy. So I was just wondering if you could give some kind of insight of what that's like, of having to deal with a project that's on such a huge scale. How often do you interact with the Spanish colleagues and the German colleagues, etc., or do you work somewhat in isolation and only periodically share how the progress is? Do you know what I mean?
It's quite complicated, actually. In the first half of the project, we are trying to have physical meetings. We already had one meeting for the kickoff in Brussels. We met in June in Germany. Last December we met in Slovenia, and in June again, because it will be half of the project, we will meet in Budapest, because I see also my colleagues connected from Budapest University. Being it's just a colorful, let's say, side of the human interaction. Being such a big project, you need also big rooms. So universities are more likely ready to host such a big number of people. There are layers. So there is a coordination team. So each pilot leader is having a monthly interaction with the coordinator to understand the common issue. But each and every stream, there are 10 work packages, and the pilots are split in several work packages. We are having monthly meeting at work package level and more frequent meeting in task single activity level. So it's I don't know, not the soap door by door reseller companies, the multi-level marketing, but it will be a multi-level coordination, and the approach is more about creating a cooperative environment and trying to understand the problems, anticipating the problems, and try to move ahead smoothly. There is a technical coordinator. It's UBTech Energy. The supervision of Professor Monti, the coordinator, is ensuring also let's say privileged point of view, because he's very expert. Actually, I mentioned a protocol, Villas framework. Actually, it was his department who was developing this protocol. So we're very lucky to work together. But for example, in the Italian team, we have RSC, who is making a good and excellent pivot. I'm not a basketball player, but the pivot, it's always the element who is connecting all the tall guys and making the interaction work. Because together with the Italian pilot, we have Slovenia, Germany with 3 pilots, and Hungary. So it's quite complex, and we need to collect, interact with other working package, for example, of the requirements, all the technical implementation, understanding the roadmap, interacting with the platform. So there are a series of interaction, and plus the team from RSC, they are expert in BIM models. They were already cooperating with Enel Grids and also with other DSOs in northern Italy for the adoption of BIM models in the energy field. They already experienced an integration of BIM and SIM. So it's a quite heterogeneous group of partners, and it's quite stimulating to work together. Also with the university, because they have a different perspective. I'm not young anymore, so what I studied in the book, it's a bit outdated, and mainly those who are. I'm not in this case, but usually when you work in an industry after several years, you lost a bit the connection. So you are more, let's say, step-born on your habits. We already did it in this way. All the rest, it's not good, but the university is more free from this stereotype and constraints. So it's a good way how to make comparison and interacting and grow together.
Yeah, it sounds challenging, but also rewarding, like you say.
Yeah.
I see that Sam has raised his hand, so I'm guessing that he wants to unmute and ask another question. So
Yes,
please go ahead, Sam.
Hi, Danny. Thanks for that. I think it's super interesting, as I said in my first question. I'm just wondering, what I'm just getting back to this idea of the definition of a digital twin. So I've been sort of studying digital twins on and off, probably, I don't know, 5, 6, 7 years maybe. And really the first one I ever came across was, and the one I sort of always go back to, is the Formula One digital twin. Just because it's the best definition of one, because it's one of the few places where, you know, they had 30 or 40 years worth of data on their past history. They then reach the point where they have unlimited funds, let's say, to win a race, and they can then also, because they've got a very defined space, which is a car and a racetrack, they can then drop as many sensors as they possibly need to into that car, to the point where they have an almost perfect representation of the car. Then they go and take that data and they produce a computer program to run the car against. and then they set the car up for, Monaco or whatever, and they plug in the data that they're getting on the day the week before, and they run the simulations. And at that point, you're still really just running a model against a model. You haven't quite got to the full, what you might call the actual twin at that point. And you actually end up with the twin on the day when Lewis Hamilton gets in the car and actually starts driving it. And of course, by that stage, he's plugged into, probably some kind of body monitor as well. So they're, they can do everything from, what temperature his body's running at to what temperature the car's running at. And I just sort of wonder, do you think that we will be able to get to that level of digital twin in the electricity system? And I mean,
actually, there are already implementation who are working for several years. Let me mention the ADMS system, Advanced Distribution Monitoring System, that it's providing a series of extra features to support the control room operator whenever there is a extreme weather condition. So making simulation of scenarios. This is already there at least 15 years. So nobody was calling it twin. They were calling it IT tool to make some simulations. And there are a series of tools in different directions. So there is not a unique twin. There are multiple simulation tools. For example, when you have to connect, in my working experience in Enel Group, I did a lot of jobs. One of these was for 10 years connection of prosumers. So my colleagues from the technical department had to run the energy load flow calculation to understand if that specific producer in that specific point of the grid was the grid was able to provide him energy or provide him capacity, but in the same time that prosumer was not jeopardizing the system. So a series of calculation tools are already there. The complexity is that to make them interoperable. So what I was describing at the beginning is that we are not aware about how many systems, more in general. I know that every company knows or should know, because for big company, the right hand doesn't know what the left does. But there are plenty of systems. In my previous projects, just to mention advertising, Smart 5 Grid, I was coordinating the project. A colleague told me that, look, the virtualization of field devices, it's already a digital twin because you are making a replica of a physical tool. And it was we were implementing virtual devices to preserve the stability of the transmission grid between Greece and Bulgaria. So to comparing the frequency among the country, we were converting in the signal, the information in digital. And the story was that in the analog system, they have a very limited number of samples. With this digital tool, they have 60 samples per second, 50, 60 samples per second. That is an enormous number of information. Yeah. So from that, you can start analyzing the data series and understanding if there are patterns. So the definition of the digital twin are multiple. You can't have a comprehensive definition. The topic at the end of the challenge at the end of the project will be to give a comprehensive definition of what could be considered a digital twin. Cool. And understanding how they can interact. I mean, today we only saw specific implementation of the twin, but not the general, because we might need a week of webinar involving many other people.
I like the way you linked it up to the BIM system, because obviously the BIM is the basis of some of that, and then you basically have to hang all of the rest of the digital twin on your baseline case given to you by your BIM. So that bit was quite, when I saw what you were doing, that was quite clever.
But I like to use a metaphor that I'm coming from IT system, and the same thing depends on the perspective you look at it. It can be visualized differently. So, for example, think about any software for the front office and the back office. That there is the final customer that is going there and they see what is the front office and front end. But for those who are working inside the company, they say, "Oh, what our customer wants that is very creepy. What is this request?" So, but they have a different perspective because they work inside. So the twin, it's a way how to create a replica of whatever is going on in the physical layer. It's also a replica if you think about all the SCADA systems. They are already a replica of the power grid, and they are on place dating back in the 60s.
Yeah.
So it's already there. So we need to build and join the pieces of the puzzle to make it interoperable.
Yeah, so I've seen some super cool. I mean, I think the twins they're kind of, for me, they're coming on in leaps and bounds, and they're getting closer to the Formula One. There's a fantastic example in there's a Canadian airport, and Vancouver Airport was one of the ones I thought was really exciting, because you've got so many humans involved as well at the same time. Anyway, thank you so much.
No, thank you. Yeah, sometimes it's not easy to explain such a complex and complicated project, and the questions are also helping to give a better description, let's say. Okay.
Okay, great. I'm not seeing any more questions, but we are also getting quite a long time already. So we should probably bring it to an end anyway. But you did show your email address at the end of your presentation, right? So if anyone has any more burning questions for Daniele, you can definitely reach out to him. Yep, there's his email address one more time. So thank you to everybody for coming, and we'll see you at the next one. So thanks very much, everyone.
Thank you, everybody. And please follow our social media of the project, our website. There are plenty of materials, and stay in touch. We will come up with other contents in the upcoming future. Thanks all for joining us today.